doubt knows Josephine. I think that they're related. Is maybe one's named after the other. I can't say. Joe is playing his open-ended pipe. He's also in a pipe band, turns out. And the frequency of the second harmonic is 880 hertz. Well, if it's the second harmonic, maybe this is information that we could have read between the lines on, right? N equals 2. The speed of sound through the pipe is 350 meters per second. Okay, so there's some given information as well. And I think if I want to find the length of the pipe for Joe's second harmonic on his pipe, I'm going to write down my givens. N equals 2. The frequency, I'll write F sub 2 is equal to 880 hertz. And the speed of sound inside of his pipe is 350 meters per second. Now, just for argument's sake, let's just let this 350 be a 3 significant figure value. We'll put a line over that 0, okay? Some people like to put a dot after the 0 to show that it's a significant 0. But anyway, 350 meters per second for the speed. And if we want to know how long the pipe is, maybe we should draw this illustration first, because it's the second harmonic for an open-ended air column. I'm going to draw it vertically because I always think about playing the pipes vertically. It would look like this. If you look at this video on a phone later, you can rotate it yourself, but I'll rotate it right now for people in the class because it would look something like this, right? Think about that candy bonbon that's twisted off at both ends, okay? And when I look at this waveform, what I would say is that from here to here is the length, and I know there's a formula for this, n times lambda over 2 for an open-ended air column, able to fluctuate at both ends. And so that means that if I want to know what the wavelength is, let's see. What do I know here? I should figure out, if I want to know the length of the air column, I should figure out the wavelength. So I'm trying to find the length of the pipe, the L value. So I say, all right, well, V is equal to lambda F. And there are people that say we should really index everything. Speed is equal to lambda 2 times frequency 2. And people say, well, why would you specify lambda 2 and frequency 2? Because, of course, there's going to be wavelength 1 and a frequency 1 for the first harmonic, right? There would be different lambdas and different frequencies. For the third harmonic, there'd be a lambda 1 and a frequency 3. So I got to keep track of things. It's kind of like in kinematics where we had subscripts to keep track of which one was which. There might be different wavelengths for different harmonic frequencies, right? So I'm going to take stock of stuff in that way. So maybe I should say this is F2, this is F2. I want to find lambda 2. Now the speed doesn't change because in theory, the speed of sound should be a constant in a given instrument, right? It's going to be the same value because it's the same media that's transmitting the sound. So I can say, okay, well, lambda 2 is equal to V divided by F2. 350 meters per second divided by 880 hertz. That gives me my lambda 2 value of, I get 0.39773 meters. Did anybody solve this one and get that value? Beautiful. Okay, so nodding heads agree. But then I say, if I want to know the length of this pipe, then we say, okay, well, L2, playing the second harmonic, that 2 is just to remind me that I'm playing the second harmonic. L2, because the pipe didn't change length, it's just a reminder for me. L2 is equal to 2 times lambda over 2. Well, don't those two 2's cancel out? So as a math person, I'm just going to engage in that and get rid of those guys right away. And then I'm just ready to plug this guy in and say, okay, well, that means that the length of the pipe is equal to 0.39773 meters. Now, again, just like in any other physics topic, I got to round off to sig figs. And we declared earlier that there were 3 significant figures here. So approximately 0.398 meters long. Never round off to the end. Now, question B says find the length of the first harmonic. Find the wavelength of the first harmonic if the pipe stays the same length. Of course, it makes sense for the pipe to stay the same length. Unless you're dealing with a trombone, you're not changing the length of your musical instrument, right? So we say, all right, that means that the length of this thing is still going to be, here's my musical instrument, open at both ends. The length is still going to be the same, where Ln is equal to n times lambda over 2. but it's the first harmonic. So that means that n is equal to 1. The L value is still equal to the unrounded 0.39773 meters. And I want to find the wavelength. Well, that just means I'm isolating for lambda. So I feel like I could do a little bit of isolation, a little bit of rearranging, and I'm going to get 2 times ln over n equals, and I could write lambda n for, the first harmonic, right? I'm just rearranging this equation to get lambda n all by itself. We can sub in our equation, or sub in our values, and we get lambda 1 is equal to 2 times the length of the air column, unrounded of course, 0.39773 meters, divided by a harmonic number of 1. And so the wavelength for the first harmonic, what do you guys get? Unrounded. I know there's at least 2 people that have done this already. What'd you get? Yeah, I know you got it. 0.79? Okay, 9.545? I got 4.6. Is it 4.5?
Probably the.
Is it a?
Because the 7.3 is rounded off.
Oh.
7.3 is rounded off anyways. Because it's 7.2, 7.2, 7.2.
I think it does round up to 6. Anyway, meters. But we're going to round that off to 3 sig figs anyway, so it won't matter. It'll end up being 0.795 meters for the wavelength. So I'm going to emphasize that it's lambda 1 because that's for the first harmonic specifically. And then question number 3, or part C says, what's the frequency for the natural frequency? Well, if we have lambda 1, then V equals lambda 1 times F1. Can't I just solve for F1? Remember, we're keeping track of which wavelength is which frequency is which. So F1 is going to be equal to V over lambda 1. That's one way of doing it. Another way of doing it is to say that what were we talking about? The second harmonic? F2 is equal to is equal to 2 times F1. Isn't that another way of dealing with this? And I could solve for F1 this way because I already knew the F2 value. Personally, I want to do this one because I don't know if I did this previous one correct. So maybe I'm going to use the second equation. You guys see why I would do that? So I would say, all right, well, that means that F1 is going to be equal to 1/2 of the F2 value. But both methods are equally valid. And the F2 value was 880 hertz. Look, we've got it way up here right at the beginning of this problem. So 1/2 of 880 hertz gives us 440 hertz. I guarantee you sub in V is equal to 350 meters per second, and lambda 1 is equal to the unrounded 0.79546 meters. I guarantee you're getting the same answer. Sound good? Pretty close because we did some rounding in there somewhere, right? And so I feel much more confident about this one because it doesn't introduce any previous calculations.